These videos are for April 4th, April 5th, depending on if you're a B or A day, and we're looking at the properties of logarithms to help simplify expressions. Here, we're going to start with looking at the properties, list the properties out, and then see how we can apply these properties to evaluate them. Also, I'm going to try to tie the properties to properties of exponents and explain why that's the case as well. But here, we started with the change of base formula. I'm not expect you to know this, to use this on your upcoming assessment. However, it is still something that would be useful in the future. So just write this down, know that it exists. We'll probably come back to that later in the year when we're reviewing for our challenge exam. But here, we want to look at our properties of logarithms. And the first thing we did this class was look at properties of exponents. And the reason is, if we have, for example, let me back up. Let's say we have a problem that maybe was on when we first looked at logarithms. We can write this in the logarithmic form and say this is log to the base 6, sorry, not even base 6, base 7 of 6, and say that's equal to x minus 2. With the idea being that if we have a variable in the exponent, we can get that variable out by using logarithms. Logarithms help get variables out of the exponent, and hopefully we can see here that the output of our logarithm is actually the exponent. So because of that, it would be great if logarithms behaved in the same way that exponents do. And it turns out that logarithms do behave in that way. Namely, we have three major properties that we're going to be able to look at and use when we're simplifying expressions. The first one here is the product property. So think about if you are multiplying two bases with the same exponent, we could do that by adding those exponents. And it's similar here. If we're multiplying, if we have log base A, and we're multiplying two quantities within our logarithm function, then what this would become is log base A of u plus log base A of b. Now, the biggest thing about today is that we need to go both ways. Maybe we'll see if I'm multiplying, that I can split that up here, or if I have two things that are being added, two logarithms that are being added, and I have the same base, that I can write that as multiplication. These are going to be key, especially when we solve these equations. And so I really wanted to make sure that we understand that we can go both ways in these identities. Or properties, I guess. The next property is the quotient property. And the quotient property says if we're dividing here, well, then you would subtract our logarithms. Or in other words, if we have subtraction here, we need to be able to go in reverse and say this is log base u divided by, or log base A of u divided by v. That's the key thing, is to be able to recognize when we can go in reverse. And then here, if we have something raised to a power within our logarithm, we can write that in front of our log and get rid of the exponent. So we take the exponent here, move it in the front, and that's a property that we can use as well. So now let's see how we can apply these. I'm going to do the first four here. Let you try the next few. Probably put the solutions on the next video. Here we want to use simplify this expression. Well, what a lot of people said is, hey, I have a power. I can use the power property and say that this is 2 times log base 4 of 16. That's true. I'm going to erase this just because it's clouding it. It's taking a lot of space. Here, so we have log base A, log A, log. Here, if we have something in our exponent, oh, nope, I lied. If we have something in our exponent here, we can move it to the front by multiplying in front of our log. So that's what we're doing here. Similar thing in this expression, we can move the exponent in front using the power property and say this is -7 times ln of e. Now, these actually evaluate. This logarithm evaluates to a single value. And the way that we said that logarithms, the output is exponents, are exponents. Here, in order to evaluate this log, we need to be thinking 4 raised to what power gives us 16? Well, because 4 raised to the second power gives us 16, we can replace this log with 2, since 4 squared equals 16. This 2 stays, and so this entire logarithm evaluates to just 4. Similar concept here. We can move the exponent in front, multiply by ln of e, and this evaluates as well. So this becomes a value as well. Ln, we should know, is log base e. And we're trying to figure out e raised to what power gives us e. Well, e raised to the first power gives us e, and so this is equal to -7 times 1, which gives us just -7. And in fact, this is an extension of a very good property. Anytime we have log base a of a, no matter what our base is, again, we need to be thinking a raised to what power gives us a. Anytime that's the case, it'll be 1. So whenever our base and what's inside our function are the same, that's going to evaluate to 1 every time. Let's look at these next two, or maybe this next one, and let you give the solutions to these next 3 on the next video. Here, we want to use the properties to help simplify this expression. In class, we talked about using the power and quotient power property. Power here, quotient since we're dividing. And what we really talked about is which one comes first. We do need to be careful here because the square is only on the e. It's not on the 6 as well. So we need to isolate this first. And so what we did in class is said, hey, this is going to be ln of 6 minus ln of e squared. Now we can simplify from here. Ln of 6, again, it doesn't come out even. It doesn't come out as a whole number. I think it's going to give us a long decimal. Just leave it. Here we have a power inside of our log. So because we have a power inside of our log, we can move that in front of our logarithm. So this would become minus 2 times ln of e. Ln of e is just 1. So this evaluates to ln of 6 minus 2. So this is one way that we could use the properties of logarithms to help simplify expressions. I'm going to stop this video here. When I open the second video, start the second video, I'll post the solutions for these 3. Try those on your own, see if you get the same thing. A lot of different, probably multiple ways you could do it, but see if you can get there. And then we'll go on to see how we can further simplify other expressions.